Okay, we're going to continue on with our rational equations, remembering that all of our rules from before apply. If the equation consists of a single rational expression on each side, we can just cross multiply. If it has more than one term, we multiply every single term or every numerator by the lowest common denominator, and then it should divide out evenly so we don't have any denominators left. And then afterwards, we're going to solve for the variable. Remembering we always need to state the non-permissible values or the restrictions and make sure our solution is not one of those restrictions. So when we did the first example graphically in the last lesson, we said that the solutions were that x was either 0 or 2. Now we're going to prove that algebraically. So given that it's x plus 1 and x minus 1, I know that x cannot equal positive or negative 1. Now, I have two different factors here, which means that my lowest common denominator is going to be x plus 1 and x minus 1, which is what I'm going to multiply into every term. So I'm going to have, for the first term, 3 x plus 1, x minus 1, over x plus 1, plus 1 x plus 1, x minus 1, over x minus 1 is equal to 2 x plus 1, x minus 1. Remember, I need to multiply it into every single term that exists. I'm going to divide out the x plus 1 from the first term, the x minus 1 from the second term, and that's going to give me 3 x minus 1 plus 1 x plus 1 is equal to 2, and I'm just going to multiply this out real quick. X plus 1 times x minus 1 gives me x squared minus 1, because they're conjugates. I'm going to expand it out. 3x minus 3 plus x plus 1 is equal to 2x squared minus 2. I'm going to, because it's quadratic in this case, move everything to one side of the equation. So I'm going to subtract 3x from both sides, add 3, subtract x, and subtract 1. And when I do that properly, I wind up with 0 is equal to 2x squared minus 4x. Now at this point, I can use any of the methods that we've had to algebraically solve quadratics, but if it's possible, and it usually will be, I'm going to lean towards factoring. In this case, the factoring is quite simple because there's just a common factor. I can divide both these by 2x, and I'm left with x minus 2. And I can see from the factors where there is a variable, the x that's outside of the brackets gives me 0. Or the factor of x minus 2 is going to give me x is equal to 2. And those match the solutions that I found when we did it graphically. Moving on to example 2. Consider the rational equation x squared minus 5x minus 6 over x plus 1 is equal to 2. I can see right away that x cannot equal negative 1 from this denominator. And I'm going to multiply both sides by the denominator of x plus 1. So I wind up with x squared minus 5x minus 6 is equal to 2 x plus 1s. or x squared minus 5x minus 6 is equal to 2x plus 2. Because it's quadratic, I'm going to move everything to one side. So I'm going to subtract 2x and subtract 2 from both sides and get x squared minus 7x minus 8 is equal to 0. I can factor this down and say that this would be the same as x plus 1 and x minus 8 is equal to 0, which means that x is equal to negative 1 or x is equal to positive 8, but we said up here that x cannot equal negative 1, which means that we don't accept that. It is an NPV. So the only solution is going to be that x is equal to 8. Explain why one of the solutions to the quadratic does not satisfy the original equation. Because x minus 1, or sorry, x is equal to negative 1 is a non-permissible value. We can't have an NPV as a solution because when I put it in, 0 over 0 is not the same as 2. Just doesn't work. Can't divide by 0. Continuing on, once we get to example 3, state the non-permissibles, solve, and then verify. Step 1, non-permissible, x cannot equal 0. I'm going to multiply every single term in here by x to get rid of that denominator and say that this is going to be x squared plus 2 is equal to 3x, or x squared minus 3x plus 2 is equal to 0. Now I'm going to solve this by factoring again because I can. And I'm going to get x plus 2, sorry, x minus 2 and x minus 1 is equal to 0. And x is either equal to 1 or 2. Now, neither of those are non-permissible values, so theoretically they should both work. So I'm going to double check. If I said that x is 1, 1 plus 2 over 1 is equal to 3. That would be the same as 1 plus 2 is equal to 3, or 3 is equal to 3, and the left side is equal to the right side. So I know that one works. If I said that 2 is equal to, 2 plus 2 over 2 is equal to 3, then that would be the same as 2 plus 2 over 2 is just 1 is equal to 3. 3 is equal to 3, left side is equal to right side, and both solutions work. When I get to example B, I'm going to factor this down to start and state that I have x over x plus 2, x minus 2 is equal to 2 over x plus 2. And that's going to tell me that x cannot equal positive or negative 2. Now, because there's just the two terms here, one on each side of the equation, I'm just going to do that same cross multiplying that we would have done before. I'm going to multiply the x squared minus 4 to the right and the x plus 2 up to the left, and say that this would be the same as x and x plus 2 is equal to 2 and x squared minus 4, which I know is the product of these two things. This is going to give me x squared plus 2x is equal to 2x squared minus 8. I'm going to move everything to one side of the equation. 0 is equal to, when I take away an x squared, I'm left with x squared, minus 2x minus 8. And when I factor this down, I'm going to get x minus 4 and x plus 2. So x is either equal to 4 or negative 2, except for that's a non-permissible value, which means that theoretically only x is equal to 4 should work. Don't even need to verify it because it's in my MPVs up here. But I am going to verify the 4 to make sure that that one also works. And I'm going to say that if I have 4 divided by 4 squared minus 4, is that the same as 2 over 4 plus 2? This is going to give me 4 over 4 squared is 16 minus 4 is 12 is equal to 2 over 4 plus 2 is 6. On the left side, I can divide the top and the bottom by 4 and I get 1 over 3. On the right side, I can divide the top and bottom by 2 and get 1 over 3. And my left side is equal to my right side. So yes, x is equal to 4 is in fact the correct solution. Remember, sometimes we can create equations that are actually just impossible. They just don't work. So, if I take this last example and I say that x cannot equal 3, there's my MPV. I'm going to multiply every single term by x minus 3. So I have 8x plus 10 times x minus 3 over x minus 3 minus 4 times x minus 3 is equal to 10x plus 4 times x minus 3 over x minus 3. I'm going to divide out the x minus 3 from the first and last term. And that's going to leave me with 8x plus 10 minus 4x plus 12 when I expand this out is equal to 10x plus 4. I'm going to group all of the x's together on the left-hand side. So 8 minus 4x minus another 10x should leave me with negative 6x. On the right side, if I have that 4, I take away 12, and I take away another 10, I got negative 18, which means that when I divide both sides by negative 6, x is equal to 3, and that is my non-permissible value. There's no solution. I got no possible solutions left. The only solution I came up with was an MPV. All right, go ahead, get some practice.